When you touch the street, you know, and then a cold time, you have to make sure, say, yeah, make sure, say, you have on the suit. You can't touch the road, and in a cold time, you out that door. How much degrees was it? I can't see. I can't check it. 33. 33? Yeah. Oh. But I don't really know.
Yeah. So I'm here today again, a live stream as usual. and I will be starting. Alright, so I have here a MacBook. It's a ThinkPad. Sorry, not a MacBook, it's a Lenovo ThinkPad, yeah? Let me check something here. Right, so it's a Lenovo ThinkPad, and he said that he says that something is wrong with the port. Let's hope and see that that's exactly what the problem is. So he said that the port it's not working. You have to rock it or something like that in order for it to work. So he gave these to me. This is the port, and he gave me the charger to test it. So he bought a charger. The person for this laptop is actually leaving the country today, so they should be here for it any moment now. So I'm just going to get it out of the way now. Alright, let's see. Alright, so I plug. Alright, so I'm going to plug in the charger now. You see that the port is bad, so let's see. Ouch! My mouse dropped. Is it working? Yeah, it's working. I don't want to stream long today, maybe an hour and a half maximum. Don't want to stream long today, just want to do it simple as it is. See? Yeah, I want to keep it simple. Alright, so I plug in the charger. I'm not getting anything, as you can see. Nothing is happening. Let's try the other side. Yeah, the port feels bad. Yes, the port is not right. I'm not getting anything, as you can see. The port is not right. It doesn't feel right though. It doesn't feel right when I'm plugging in the USB-C. So I'm not getting anything on either side, A or B side. Nothing. What happened? So it's straight. Let me get it straighter. Yeah. Okay, so the port seems bad. Sure, all the screws are out. Is there a screw under here? No screw under there. What the hell? This battery's so tight. Hello? Hello? Uh, the one that me not have no chip feet right now. Me not go fix that, cause I come and issue them there, Yeah. Then me not to ramp with them one day. Right, if I fix it, I dead again. Yeah. Yeah. Alright. I'm gonna check shortly. Yeah. Romain, big up yourself. Who's Romain? Yeah, who is Romain? Romain. Okay, so I'm gonna first check on the VBus. 162 configuration channel 1, open line configuration channel 2. Right, so this is my fault. So the port is bad because I'm not getting a configuration channel sensing. Right, let me check the other side. VBus dead, nothing. I'm not getting a reading on VBus. Nothing. CC1, nothing. CC2, nothing. So this port is definitely out of order, so I'll have to replace it. Oh, I didn't turn on the iron. Ah. Clinton Ramos, DJ Saint. DJ Saint, find it. Alright, these boards are very soft, so you have to be very careful, as other things can fall off while replacing. All right, so the holes are now free of solder. So I will clean. What? Where did that come from? Hold it, hold it, hold it, hold it. Ouch. The two of them popped off there? See that? I accidentally killed the board now. So the command point here would not get any power. How the hell did that popped off? Where is the next one? What the hell? Alright, so. Alright. Pour it. Pour it, 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 pour it. Yeah, yeah, GK. Yeah, man of the match. Yeah, yeah, you like it, you like it, you like it, GK, you like it. more popped off here again. That was the clamp had an extra air at schooling. Okay. Yeah. Yeah, at school. Okay. Oh, focus. Just inspecting to make sure that nothing else is not broken off the board. Why am I getting so much text now? What is going on? So I'm not seeing it. I don't understand why it's not posting. Anyway. Alright, so let's put this back on. We have another coil here to put back on. I can't find the other one. Can't find the other coil. I have to just find a coil. 0603 sizes. Alright, let's see if we find that 0603 coil. I have a 0805 cap already, so I can just put this on same time. 0805. Where is it? Right. Can't believe I end up killing the board. Oh, hold on. What if it fall on the ground? Let me check the floor. Let me check. Over here. On the ground. Alright. Richard Smith, good morning. I'm a tech. I also can use your services. How get in contact? Where are you from, Richard? Where are you from? What is What is that board they use to clean? What is that they use? 99.9? I use 99.9. It's a GK, you want to learn. St. Catherine. Oh! It's a Jamaican. So we have a lot of Jamaicans here today. That's very good. We have a lot of Jamaicans. So we have about 5 Jamaicans or more. I don't know. That's what I want. That's what I like. Alright, 0403, 0603 inductor. Do I have it brand new? Why do I have that? Lights and nolly. I can't bother to go inside of the bin right now to find out 0603 coil. But I have it brand new, right? Yes, I have it brand new. Where can I get 99.9? You can get it at the nail tech. Most of the nail tech stores that do nails and nail polish removal and stuff. You can get it at any of those places. $0603, found it. $1. So Richard, you have a shop, right? You have a shop, right, Richie? Alright, 0603. No work from yard did before. How you met me? How you know me, Richie? Oh. Here on, make me mash up the board, man. Here on, man. Here, look what you make me do now, here on my gaze. If I don't put back this cap, I kill the board instantly. If I don't put back this cap, the board is dead. Once I plug in the power, if I ever plug in the power on this board without putting back this cap, the board gone. The CPU will die. Burn. Heron, what you fixing now, Heron? What you repairing now, Mr. Heron? Mr. Heron. Right, so I have to pay very close attention to the circuit. This is the boost capacitor and this is the boost resistor, right? any fault between these two components, what will happen is that the upper MOSFET will become under conduction. So the conduction is not satisfied and it will burn the MOSFET and send 19 volts and hit the CPU, which is going to cause a lot of problems. La la la. But don't get any new programmer as yet. Heard of you. Word of mouth and YouTube. Nothing, just reach work. Have two bias issue laptop. Okay. My battery died. Didn't get to hear your answer. What? Answer that. Oh, I use 99.9 to clean the board. Anyway, literally stuck on the one I tell you about the MOSFET working condition. Hiran, mind you damage the board, Hiran. Remember, you're not trained in a Hiran. You're not a trained professional yet. So if you damage the board, then that's your bad luck. You need to get training. Alright, so I'm going to test the port now. This is the new port, right? Yes, it feels nice. It feels nice. Plugging it in. Let me check the solder joints. Yes, the solder joints is good. Right here on, you're not a trained professional, is it? So take your time. Don't rush it, or else it's gonna cost you. Rafiq. Yes, Charles. Alright, so VBus. Excellent. 154. CC1. Open line. CC2. Uh-oh. So CC1 is not reading CC2. Let me check let me check the B side. VBus 154. Configuration channel 1 603. Configuration channel 2. Oh, so it's normal. So it only use 1 instead of 2. So it doesn't use 2, it uses 1. So each manufacturer of boards uses different configuration channels. Alright, so let's see if we're getting some boosting and some signal, some voltage is generating now. Yes. And the board is on. Alright, so we're getting 19 volts and we're getting 750, 600 milliamp there. Alright, and as you can see on the DC power supply, so the unit is perfectly working now and it's boosted. There we go. And what happened what normally kills the board is that when people are removing the ports, they tend to rack it out. Doing this, when you rack it, you break the port, and what happened that you can cause grounding inside of the pins. So you can send grounds and voltage and ground when you rack it. So the perfect way to do this is to like this, straight out. Alright, so I just need some more solder here. Firm it up some more. Firm the port up some more. Look, see that? The port fell out. How is that possible? Oh boy. Straight out. And the port fell out. How is that possible? Look. I don't like these Lenovo boards, they are too soft. Let me go again. The port fell out just like that. The port fell right out. Having the heat too long on these boards, what will happen that the components on the other side of the board will start falling off. So you can't put too much heat on this or you're going to be in trouble. Alright, feels firm. Let's power the board again. Yeah, so it works. Five. Four. 8. It's 50 minutes since I'm streaming already? You serious? 54 minutes. Alright, so I'm going to put it back together now. All right. Oh, 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 oh. You hear that? The unit is on. That's crazy. How is that possible? Yeah. All right, so that's finished there. Hey? Now look at that. All right, so it's now charging. We're getting 2.6 ampere. So that indicates that the battery is charging. Very important. All right, so the battery is charging. 68%. Let me see if I can zoom in on this and capture it. Hello? All right, so I'm now at 72%. So it was 68, now it's charging. All right, so this is finished. All right, so this is done. All right, so this one is GK. This one is dead. It's another Lenovo. This one is dead. Is it a Type C? No. It's a regular one. Alright, so I'm plugging in the charger now. This one is dead. I'm getting 50 milliamp there. It's fluctuating, jumping. Oh, it's actually, is it what's that? Oh, GK with the burn. Oh, the battery's already pulled out. Got this from a, oh, so we have the burn spot here. This is, it is burnt. You have a dead short there on that coil. Is it repairable? Let me see if it can be repaired. But this is normally shorted. Oh. Oh, oh, oh. Oh. So this one most likely burned, maybe hit the CPU. Ah. Okay, okay. This one is a nightmare. Everything here is burnt out. My God. Still short. So the CPU is dead, so we know that this goes to the RAM. Yes, there we go. So the RAM is dead. These DDR4 RAMs are all gone. No, it's not. It's not the RAM. So we have 3, 5. Yes, it's going to the CPU. We have a short here. This is a mess. This is a mess. It's a mess. A mess. This is dead. CPU is dead. The CPU is dead on this one. I don't have the CPU. This one is a CPU issue. The CPU is burnt. The CPU is burnt on this one. So I will not go any further with this one. This one is a dead one. To the next one. Okay, I have here Apple. The internal screen is not showing. They said no internal screen. It's a A1932. A2179. It's a T2 model MacBook. No internal screen. Alright, so this one, I said no internal screen, but it's not boosting. So as you can see, I get in 5 volts, but it's not turning on. It told me that it's not seeing anything on the screen. But the laptop is just not boosting. It's 5 volts, but it's not boosting to 20 volts, or 19 volts rather. I'm not getting anything from this. Alright, so I'm going to take it apart now. Apple is slowly taking over the repair industry. I repair more Apples than I repair ordinary computers, or Windows based computers, or PCs. I repair more Apples than anything else. Most of the time I'm always repairing an Apple laptop. Oh, that's liquid. I see traces of liquid here. Alright, let me do some inspection on the board. Alright, there we have some liquid here. Let me see over here. The board is pretty fine. This side is not so bad. Some splashes right here. Hold on. All right, so checking up the side. This is the T2. All right, the T2 power PMUIC. All the section is good so far. I haven't seen anything. Let me. Lost the feed here. All right. All right, taking it apart now. Hello, Chipmaster. What's your favorite vintage sound producing IC? What? Any bit? Fever Dreams. Who is that? What's your favorite vintage sound producing IC from the 80s? I'm not sure. What is that? I'm not sure. What is that? Alright, so I'm checking this side of the board. Seems pretty good. For example, Yama chips for same. Oh, I see what you're talking about now. I see what they're talking about, the audio from early 80s and early 90s audio chip from SID C64. Alright, hold on. I'm just inspecting this board first. Soon get back to you with that. All right, so I'm here inspecting the board. So the inside of this, the CD3217, oh, CD3217, and the A1932 uses the C321500C, is version 0 or version Z. All right, on the backlight supply area is all good. Everything here is good, no liquid intake, won't burn anything. All right. Yeah. So I'm going to connect the port. Remove the port. Yeah, sorry about that. Is this the fine one? This is not, oh, he's in the wrong one. All right, so I'm gonna test. This port doesn't look right. We have some corrosion here on the port. All right, so testing. All right, V-boss. Oh, boost speed. See? All right, so V-boss. V-boss. I have 123. CC1, 566, CC2, 566. Next one, V-boss, 123, CC1. No reading there. CC2, reading. Oh, CC2 and CC1 has reading now. All right, good. It's not boosting. Still at 5 volts there. Next one. Still not boosting there. Alright, so PP bus. No short there. No short on backlight power supply either. Alright, 3 volts and 5 volts. 3 volt is good, 5 volt. 5 volt is good. This is 8 volts. PP bus. Alright, this is VCC SA. VCC SA is good or not? Yes. 189. CPU core. Yeah, that's good. See, next one. This is the graphics. Bit high. And this is the non-power supply 2.5. Excellent. So we have no short, but it's not boosting. Alright, let's check PP3V3 linear output. Yeah, that's good. Next one. All good. Yeah, that's good. PPDC in. Yeah, that's good. Next one. Yes, that's okay. That's good. That's good. Alright, bias input supply. Yeah, that's good. Now we're going to have to check now to see if the T2 is getting power. Alright, so the PMU not getting anything on the PMU ICs here. Nothing. So the PMU awake, PMU SOC, nothing. So the T2 is not starting. So the T2 we need, here is getting 12 volts, but not getting any voltage there. Alright, so we're getting 3.3 volts here. Nothing. Are these ports working? These ports doesn't look right. A lot of dirt. These ports not looking good. Try again. All right. Yeah. Not getting a voltage here. It's getting 5 volts, PPDC in, 5 volts is coming in. Is the RAM chip getting 3.4 volts is here, the RAM chip. No voltage coming out. Oh, we have a 3.4 volts here. Yes. Next side 1.5. Nothing there. .4 volts is here now. 1.5 here. Nothing. Alright. Let's see if the charging IC is working. There's a charging chip here. 1.2 volts. 5 volts is there. VDD. VDD-A, VDD-P. I'm not getting 8 volts. I should be getting 3.3 volt linear here. I'm getting 1.2 volts. That's abnormal. Free DNA? What? Three volt linear. All good. Charging circuit here. No short. No short there. Let me dust off the board here. .2 volts. This is the 5 volt input. Alright, so I'll have to head for the schematic. Let me go for the schematic. So that's a 820 hyphen. Alright, it's a 820. This board number here. Don't tell me that it's under the CPU. Yes, it is. This one is under the CPU. That's it's 820 01985. Alright, it's 820 01985. Hey? Oh, 01958, sorry. All right, so here for the charging chip. So here's this section here. So we get P in, right? So we're getting 5 volts here. So after the 5 volts is coming in, then it release VDD-A will come out and to power VDD-P. After VDD-P is powered, then the gate Q1 will conduct, and this is the 4-switch buck boost regulator circuit. So as you can see, voltage comes in and comes through this MOSFET's drain pins, and then it will go into boost mode because it's taking the 5 volts and then converts it to 12 volts to PP bus. So I'm not getting PP bus, which is the 12 volts coming from this charging chip here, right? After that voltage is generated, then it will release the enable signal. We have this one, enable, which is not connected, right? We have enable charger MVR. Right, so it's coming here, and this is going to output PP3V3 GT RTC. This is what we need to power the PMU IC. So we need to check if we are getting the enable here at pin number 13 from the charging chip. We can check out this resistor R6960, and that's the edge of the board there. This is all right. I'm just aligning the board view. Alright, so we're going to check here. PP3V3 RTC, this coil. Sorry. And it's good, there's no short here. Alright, so let's see if the resistor is getting the enable signal there for this chip. This is the enable signal. And there's no voltage there. No voltage. And we need PP bus. So I already checked PP bus already. Alright, as you can see, PP bus is good. There's no short. No short at PP bus. So could it be that the charging chip is bad? The ISL? Alright, so here is the ISL. So we get P in. 5 volts coming to P in pin. Once it get P in, the next thing we should check is here. These two capacitors, C7075 and C7077. I checked here. Let me check. I get 5 volts here. Alright, it's 5 volts there. Yes, I did check 5 volts here. Yes, we get 5 volts, 4.8. And it's going to through a 4.7 ohm resistor to power VDDP. And here we have here 4.9 on the next side. We have 4.9. Yeah, that's good. That's good. So VDDP is getting power. Yes, 4.9 volts there. Okay. Because the thing is, we're not getting to 8 volts, 12 volts for the pros and 8 volts for the airs. Right? We should get, once these MOSFETs, this charging chip will start conducting, right, into boost mode. And we should get voltage here, PP bus. Right, all this side here is PP bus. Alright, so I'm just confirming with the schematic. Current sensing resistor right here. Some caps here below. And 12 volts is not here. We're getting 1.2 volts. So I'll have to replace this. We should get in 12 volts here. 8 volts, sorry, 8 volts. We should be getting 8 volts here, and I'm getting 1.2 volts here. So I'm going to replace the ISL and see what I get. Because there's no short on PP bus. Let me check again and show you. As you can see, there's no short there, all fine. But I'm getting 1.2 volts. And I'm not getting any short on PP3V3 RTC here. Right? There's no short nowhere on the board for these voltages to produce. So everything is coming from the ISL here. These are charging IC. So I'm going to replace. Ryan Labs, hello. Yeah. Expose wafer BGA, always fun. Yeah. Expose wafer BGA. Alright, so I'm going to affix another charging control IC there. You enjoyed it? You enjoy doing that? Alright, so this one is broken. Just inspecting the bottom of the chip here to see if I see any well, it looks good. Okay, so I have a donor board here, which is on another ear here. This is a M1 board, so I'm going to take it from this one. I don't do them often. BGA, you don't like to BGA rework, repair? I do BGA, just not expose wafer. BGA, I don't repair MacBooks, PCs, or phones. Okay, I see what you're saying now. Oh boy. Few times a year I'll get a controller with an exposed wafer BJ needing replacement. Okay. Just getting the right stencil. All right, so I'm going to rebar this charger control IC. Oops. Really? I have to fold it some more. Amazing Apple did not underfill that one. No, they didn't. They only underfill like the nans and the... Oh shoot. Oh my god. Where did that fly? I lost it. I was looking at the thing while reading and it just slipped off the tweezer. Oh boy. Oh, here it is. Found it. Oh. Alright, so I'm going to Alright, so I have moved the excess balls. Cleaning the BGA. Alright, so I'm gonna reball this now. Alright, that's done. Alright, so pin 1 is right here. Alright, so I'll solder. Okay. Alright, so let's do this. One more. Really? Alright, so don't think that one is solid credit. Anyway, VPP. Oh, we have a short here. Is this strip good or not? This is not right. This is not right. I think I created a short. No, there is no short. So this chip is bad. Alright, I'm gonna try and catch it again. Alright, I get 199, 299. Yeah. Yeah, that's good. Okay. Let me try add some more. Okay. Alright, so I'll make it cool. Let me measure PP bus. Alright, PP bus. clear. Alright, so let me plug in the power. Is it cool? I'm not getting 3 volts. I'm getting 5 volts. Alright, it's the same fault. Didn't boost. Still getting 1.2 volts there, as you can see. So it's not the charging chip. Alright, so PP bus is still giving me 1.2 volts. Same thing. So the PMU IC is not getting power, and there's no short going to the PMU IC for PP3 with the RTC. Alright, so next I'll need to check some current sensing. Alright, so current sensing positive, current sensing negative. And there's one for Alright, so there are some current sensing resistors here. Let me check them. They are how many ohms again? 1 ohm resistors. Oh, this one is tough. This one is tough. Yeah, that's good. Yep, they are good. These ones are also good. Within ohms. 1 ohm, this one. Measure again. 1 ohm. So the resistors are okay for battery and adapter sensing. PP was sensing. Alright, so there's another P-bus power and cell, and that's coming from VDDA, coming to G4 pin of the cell pin, and P-bus power, that's also good. How long am I streaming now? 2 hours. I think I'm gonna stop. Just checking I'm going to try another port. (12:25 p.m.) These ports doesn't look right. All right. All right. All right, so the ports is fine. So this one will take some brainstorming. Why I am not getting 12 volts. I gave you a superb. Few times a year I'll get a controller. I gave you a superb. I gave you a superb and a like. Okay. This one is a tricky one because there's no short. The resistors, the current sensing resistors are okay. The charging control chip is replaced, and I still get 1 volt at the PP bus. So my next option is now to check with oscilloscope now to see the gate of the MOSFETs. I'm going to turn off my Wi-Fi. Who is this? No disturbance. Alright, so yeah, I was getting, as I was saying, I'm getting 1 volt here. I was getting 1 volt, so there's no one, it's supposed to be 8 volts. So these are the MOSFETs. These are the MOSFETs. Q7030. And the gate. Let's check in on the board view here. We have gate 1, which is on pin number 1. So as you can see, we have charger. Oh, I'm not on it. Hey, somebody coming? MOSFETs are good. That's what I'm checking now. So we have charger gate Q1. Alright, this is the gate. So I'm going to check the gate with the oscilloscope to see if the charging chip is actually sending out a pulse to boost, to take this 5 volts and convert it to 8 volts. This is a 4-switch buck boost regulator circuit, and this is the other MOSFET. Right, and this is gate Q4. I have PP bus in the middle here, and these are connected to the ground. So this is the lower MOSFET, and this side is the upper MOSFET, and this is its gate for the upper MOSFET, and this is the gate for the lower MOSFET. Alright, and this is the gate for the lower MOSFET on that side, and this is the gate for the upper MOSFET. So when so in the boost mode, right, the voltage coming from PPDC in, which is here, which is 5 volts, coming here, right? When the gate Q1, so we have Q1 gate, this MOSFET will conduct, right? This one will cut off, this one will cut off, and this one will go into a continuous switching to produce PP bus to system. Right, so this one will conduct gate 1, right? So gate 1 will conduct, right? And gate 2 will also conduct Q2, right? Right here will conduct as well. So these two gates will conduct, right? This one will cut off, this one will cut off, and this one now, which is the second MOSFET, which is gate 1 here, which is going to be conducted continuously. Oh, you showed me?
Yeah,
oh, this, alright. Yeah.
You can get back there, call me.
Yeah.
That one, the fine one.
Oh, alright.
Yeah, man. I respect.
Yeah. Oh, sorry about that. I just got another laptop there. Alright, so gate 1. So this is going to a continuous conduction. Alright, so I'll have to get the oscilloscope. This one is a very tight one. This one is a tight headache one. Alright, so I'm getting the oscilloscope ready. All right. All right, so the oscilloscope. Yeah, so I'm gonna check on the gate if we're getting any wave here. Oh yeah, I'm on the right side. All right, so gate Let me confirm. So it's Q7030. Alright, so this is Q7030. Alright, so I'm going to set my volts per division to turn on, 10 volts per division, and my time base is 1 millisecond. Yeah, and my edge type is gonna be rice. Alright, so I have to use the switch to capture this one. There we go. Didn't catch anything. Not capturing anything. Oh, let me set my trigger level. Is my trigger level set right? My trigger level is 950. My trigger level was not captured. Let's go again. Nothing. Let me. All right, let's go again. All right, so the charging chip is not releasing anything there. Let's try this one. Not getting a boost. I'm not getting a boost. Charging chip is not working still. There's no protection. Right, so there's no, let me check the gate resistance. Let me check the resistance at the gate if there's, oh. Turning off. Right, let's check the gate resistance. Is it discharging? So the gate is discharging, as you can see. It's discharging slowly. Let's check the other gate. Yes, it's discharging. Let's check this gate as well. Yes, it's discharging. This one. Yeah, discharging as well. Yeah, ready? Yeah, that's good. Very good. Alright, so the MOSFET gates have to discharge. So we have to wait for them to discharge. I'm going to go on the oscilloscope again. I'm not getting a wave, so that means the charging IC has not done its work. Ready. Alright, I give power. Nothing is going on here. I'm going to try another charging IC. I'm going to take another one from another board. Yes, it's a tough job. Okay. Just checking. Okay, sorry about that. I was just checking some text. Very much. My alcohol. Oh. Okay. Alright, so we have clear resistance on all gates, so that indicates that all is well. And this is PPDC in. And this is ground, all grounded. Yeah. And all the gates are low MOSFET gate. This one, 493. For that. Let me check here. This gate. It's connect direct, so why am I getting a reading? This is abnormal. Let me confirm. This is it. What I took off. Let me just clear it here. I want to do some comparison. This is the M1 baseboard. This is the M1 board. I'm not sure about that one. All right, clear. This gate, clear. Right. So, gate here is good. That gate are the adjacent. Let's check in on. Let's go again. At this gate, I get open loop. That gate, no reading. This gate, no reading. And this gate. Alright, so it's clear because the charging chip is removed. So this one, I'm getting a reading here. This is not right. Alright, so it's now fully cleared. Okay. I'll change that MOSFET. Alright, so take this one from it. Perfect. All right. I don't know. Measure. All right, good. All right, clear, 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 clear. Trying to line this up. It's not staying in one place. There we go. Alright, so VDD, VDDA, VDDP. Okay, P in. Alright, that's good. And the gates, yes, 700. This gate, 702, excellent. This gate, 3, this is for the ground, 374. Alright, I'm gonna plug in the power and see what happens now. Yes, and I get boosting, and it worked. Yeah, yeah. Christmas, it worked. Chris, it worked. I fixed it. Yes. See this? See this? Chipmaster did it again. It worked. It was the MOSFET that was broken. So let me switch over to the schematic. So as I said before, this MOSFET was broken. This gate was leaking. This gate is the culprit for the lower MOSFET. Right, this one should be used for cutoff and then continuous conduction of this one, as I said before, Q7030. Was it Q7030? No, sorry, it wasn't Q7030. This MOSFET was broken, right? So the gate of this MOSFET for continuous conduction, this MOSFET gate must be always continuous conduction in order to put this MOSFET into boost mode, right? So if this MOSFET is not coming into boost mode, then it cannot output the voltage, and the voltage was dropping to 1.2 volts, as you can see, right? So this gate and these two gates are the crucial part of the boosting part, right? Let me get my pointer fix. Do I have it on my computer? P-O-I-N-T. I don't have my pointer fix. No? Anyway, so as you can see here, this gate is going to control this gate here, G1. This MOSFET will take the 5 volts, right? As you can see, combo, meaning that it's a setup voltage. This is called a hybrid circuit, right? So this voltage in battery mode, the voltage will flow from the battery section here, as you can see, PPV-BAT, right? This is the fuse for the battery, and it will come through this P-channel MOSFET when conduction is taking place. Then it will come through this current sensing resistor here, right? And then it will flow through this circuit and through this coil, and this is called on OTG, right? This is called USB on the go to power the USB devices that is plugged in on your Type-C device, right? So the charging chip supports the USB on the go, which is for the OTG, right? And that is used to enable to turn on the power supply. So this circuit is a hybrid circuit, right? So this charging chip is a very powerful chip, and it is used to control the 4-switch buck boost regulator circuit, right? So the 4-switch, so we have 1 MOSFET here, 2, right, 3, 4. So that's 4 switching, and it can go in either buck mode or it can go into boost mode. So each time you plug in the charger, 5 volts comes to PPDC in right here, right? When 5 volts come to this section, it will flow through this MOSFET and it will become boost mode. So the voltage here, the waveform here is going to be very dense. The voltage here is going to be very dense, and when the pulse is here is very dense, this MOSFET, this is a typical PWM circuit, right? We have an upper and a lower MOSFET. So these MOSFET comes in conduction and take that 5 volts and boost it and ramp it, and with the help of this MOSFET, right, this MOSFET here is going to be a continuous conduction to take that 8 volts and turn it into PP bus, right? So that's how that circuit works. So now I'm going to demonstrate now using the oscilloscope, and I'm going to show you the waveform of the gate of that MOSFET that I've just replaced, right, and show you how it goes into boost mode. right? And in battery mode, it goes into boost mode, and from 5 volts to 12 volts or 8 volts. So let's take a look. Right, so let's take a look. Let me switch to the microscope. Yeah. Yeah, Merry Christmas. That was cool. Yeah. It was a tough one, innit? Very tough repair. Yeah. It was the MOSFET that was leaking. Alright, so where am I now? Where am I? Right, so this MOSFET gate, I'm going to check it with the oscilloscope. Oh, yeah. It's a bit cold here. Alright, so let's check the waveform. So we're going to check this now for boosting. Alright, so let's do this. So the gate is here. Right, we have 2 gates, so we're going to check this gate first. Alright, so I'm going to plug in the power. Oops, I missed that one. You see that? You see the wave? So take a look at the waveform there, as you can see. See? That's the dense waveform there. As you can see, that's going into boost mode. I'm going to see if I can capture this signal. So I'm going to use the single trigger function. I want single trigger. Let me find it. This is so we're on normal, and I'm going to go to single, and I'm going to set my time base to 100 milliseconds. As you can see, look at the dense of that waveform. Look at that waveform, how it's dense, as you can see there. So the waveform there indicates it's going into boost mode. Right? This is boost mode, if you notice. So let me go again. So I'm going to remove power. I'm going to remove power, and I'm going to give power again. Take a look at the gate. So this MOSFET is very important and crucial for the providing 8 volts. Take a look. Didn't capture it? Oh, I need to clear the screen. It's not capturing. All right, let me go again. Let's go again. All right, so I'm going to give, am I on the microscope? Yeah. So I'm going to give power. I'm not capturing anything. Let me check my trigger level. My trigger level is, yes, my trigger level is in range. I'm at 100 milliseconds. All right, 50 milliseconds, I'm at 10 volts per division. I'm at rising edge. And my time base, let me see what auto is. Oh, my USB, let me unplug. Let me plug in again. All right, there we go. All right, so I'll turn on. All right, I'm capturing something there. All right, so let's give power. Yes, there we go. There it is. So, as you can see, let me go to the normal. Let's go and capture it again. Take a look. See, that's buck mode. As you can see, the waveform becomes very dense, and then after, there we go. There we go. Let's do it again. One more time. All right, let's go again. All right, so I captured that signal, as you can see. That's the buck mode. That's the boost mode, sorry, because we're taking a lower voltage to a higher voltage. Right? So that's how you should check 4-switch buck boost regulator circuit on any Type C computer system. Right? And that concludes the repair. So I'm going to take it, assemble the unit now, and then I will end the stream after assembling the unit, right? You enjoy that repair? You enjoy the repair? tough repair, innit? Alright, so let me screw this up. Did I put the screws here? Yeah. Is that right? So was this the correct way? This is the correct way. All right. Is Heron still there? Heron, are you there? You still watching, Heron? No, no, okay. I was actually this part is always a I'll have to catch it with a screw. This part is a bit tricky sometimes. Very small board. Yeah. It's a small board. Similar to an iPad board. The hell, this thing is not clipping on. This one is giving me a problem to clip. It's a correct one, yeah. It's not clipping. Let me go under the microscope for this one. I just want to see what's going on under the board here. Under for it's not to clip. Why it's not clipping down? All right, it's now on. This is the next part that's always difficult to clip on, the LCD connection. Very troublesome. Alright, it's on. Wi-Fi. Yeah. Hold on. Sorry about that. Alright, that is connected. We have one more connection here. Alright, so I subscribed. You didn't subscribe before? Alright, so I'm gonna plug in the power. Remember, we were only getting 5 volts at the DC jack. So now, as you can see, we are now getting 19 volts. There we go. So the job is done there. First time to see you. Okay, no problem. Thank you. All right, so that one was a tough one. Wasn't expecting the MOSFET to break. All right, this MOSFET, that little teeth. Oops, what's up? Caused the computer to break. This little tiny thingy. That MOSFET was my culprit. That took me all this time to figure it out. This one. It's going to boot fast because slow because the battery is not sensing at the moment. Yeah, very tiny. Are they going to fly? Are they go flying? They are hard to find. So yes, when they fall. So the fan is spinning fast. So it's going to be a bit slow. So here's the mouse. It's going to move slow because I didn't connect the battery. So it's taking a longer while to boot up the operating system. So the fan is actually spinning fast. That indicates that the response time is going to be a bit slow. All right. All right, so I'll just remove and add the battery. All right, see if it can turn on the battery. What is the schematic software? Shinjijiao. It's a Shinjijiao. It's a China-based software schematic query design system. As you can see now, we are at 1.8 ampere here, so the battery is charging. I have this one that they say something is wrong with the port. Oh, there we go. Now it's booted up and the battery is charging. All right, so that's a done repair. Alright, so I'll just hold it down. Maximum amps for the MacBooks, 4.5 ampere. Yes, it's alive. So the first charge controller was not bad. It was the MOSFET. Yes, it was the MOSFET. All right, so this one is complete. So I'll do another one if I have the time. Let me try. So I just got this one. Right, they said something with the port. Let me see what's going on. Alright, so I don't need the oscilloscope anymore. So the first charge controller was not bad. Yeah. Oh, I read that already. So secure it. Alright, so this one, they say that something is wrong with the Type-C port here. I don't know. Let's see what's going on. So I'm going to plug in the DC power supply power. Right, I'm not getting anything, as you can see. Nothing is going on there. Let's try the next side. Still nothing there. Still nothing there. So this one, they say the port. Let's take it apart. They say that the charging port is having a problem. So let me confirm it. Oh, it's the same thing. I don't need oscilloscope at the moment. I just need the yeah. All right. Alright, let me remove the battery. Alright, so I am going to plug in, going to test. Alright, so see V-bus. Oh, we have a short on V-bus. You see that? We have a short on V-bus right there. Right, CC configuration channel 1. That's okay. Configuration channel 2. That's excellent. Could it be that the port is really bad? We have configuration channel 2 and configuration channel 1. V-bus is shorted. So let me take out the board. That's not looking good. That is not looking good. Alright, so I am removing this is a lot of tearing down. Let me remove the battery first. This is my last repair for the live stream. See what I can do. Alright, keyboard out. Is this thing glued down? Oh. because it was two-side tape down. Alright, that's out of the way. Alright, the board is out. So let me take a look inside of the port for now. So PPDC, it's equivalent to PPDC in VBus. Let me check the fuse here. Yes, we have a short at the fuse here. So it's a short at the fuse here. So let's take a look at the port of this DC Type C port under the microscope and see what it looks like. You fan, get out of the way. Oh, hold it. Somebody was here soldering something here. Look at this mess. Hey, GK! Look at this mess. What is this? Somebody was here before. What is this? Look how messy it is. What is this? What kind of flux is this? This is not flux. This is acid. These burn up components. What is this? Gel flux? All right, I'm going to. So they try to solder the port, and they say that they assume it's the port is the problem. I'm not sure, but it doesn't look right. As you can see, I'm cleaning this part here. How can I get this recording? What kind of what recording you're talking about, GK? Alright, so is this port? The port looks good to me. Let's plumber's solder. Alright, so I'm trying to see if I can take a look at the port to see if there's any burn. Inside of the port looks pretty fine. The port looks pretty fine here. The recording of this repair. It's gonna be streamed. Oh, we have a break. We have something going on here. We have something going on in the port here. Let me remove it. So it seems the port is definitely out of order. The recording is going to be stored on YouTube after the stream is ended, GK. After the stream is ended, no. The stream will be saved automatically to the channel. Alright, so I'm going to remove the port. So I'm going to get my clamp. Yeah. So GK like it. They like the whole idea of the repair. Alright, so I'm going to remove the port. Alright, so the port is out. Yep, from your teachings, bro. Alright, so the port is removed. So I'm going to check the fuse now to see if the short is gone or not. Alright, so what? Activate. Deactivate, activate. Ah, boy. Oh, I see why. Just trying to get the DC power supply to show. Not sensing. Alright, so it's real time. I lost my DC multimeter now. Both of them showing? Alright, good. Alright, so I'm checking the fuse now. Yes, the short is gone, so it's definitely the port. As you can see, I'm getting 525 now. Yeah, it is the port. It is the port. So I'm getting 527, the short is gone, so I'm going to replace the port. So I'm going to prep the board. The pins, the pinouts. Let's see what we have here. Okay, so it's all good. So why did they try to solder a bad port though? Or what, I don't know what they did. It's weird. It's very weird. Alright, that's cleared. And that's cleared. Alright, so it's now ready to solder the new port. Alright, so I'm getting the port now. Is this the new port? Let me see. Does it fit? Does it fit? Oh, it's big. It's too big. Let me... Oh, it's a different one. Let me look again. Not Daniel Creary. Who's Daniel Creary again? That name sounds familiar. That name sounds familiar, but I can't pick it up. Alright, my ports are too big. I don't have the correct port. Maybe I have to find a different something close. I'm not seeing it. Alright. That's strange. Thought I had it. I don't have this. I don't have the right port, so I can't repair this one today. Okay. Alright, so this one is out. I wonder if I can modify. Can't work. This can't work. Can't work. Alright, I'm gonna stop. So that's the end of the stream. Alright, so